Hey everyone, welcome to Chem. I want to talk to you a little bit about soluble and insoluble salts. This chart here is located on your pink sheet, but I just took a screenshot of it just to make it easier to access so I'm not flipping around during the video. So let's get started. So before I go too far, I want to talk a little bit about this vocab word, soluble. Soluble means that this salt, this substance, will dissolve in water. Okay, and if you trail your eyes down a little bit more, insoluble, this vocab word right here, means it's not going to dissolve in water. So will not dissolve in water. Now, these are rules, but obviously, as with any rules, there are always exceptions to the rule. Usually, sometimes, maybe. I don't want to jump too far into this right now. I want to explain the pretty little test tubes and do a couple of examples before I circle back. But just understand that these substances, it says compounds containing, these substances right here, if you notice, look at them, these are all anions. All anions. Okay, and it's going to talk to you about exceptions. Look at the charges. Okay, these are cations. Okay, so the anion, remember when you're writing any sort of substance, the cation comes first, the anion comes second. All right, so let's check out these pretty test tubes here filled with colorful chunks of stuff. So it says, figure 12.6, if a salt contains a combination of a cation, remember cations are positive, and an anion, anions are negative, that are not soluble, that salt is insoluble, meaning it won't dissolve. For example, combinations of cadmium and sulfide, that would be the orange test tube, that first one, iron and sulfide, the black test tube, number 2, and lead and iodide, that's the yellow stuff in test tube number 3, and nickel and hydroxide, that's test tube number 4, it looks kind of turquoisey, do not contain any soluble ions. Thus, they form insoluble salts. So basically what it's telling you is that these, when in combination with each other, they are not going to dissolve in water. So that's why you kind of see those chunks floating around in there. They're not soluble. They're not going to dissolve in water. Well, what's goofing this up? So it's the question there in pink. It says, what ions make each of these salts insoluble in water? So somebody's messing up the flow. Okay, and that's where that chart above comes in. So if we look at that first test tube with the orange chunks in there, okay, what ion is making each of these salts insoluble? Well, if we are going to check out our chart up here, we're looking at cadmium and sulfide. Well, sulfur, that's the anion. So I need to look in my green boxes here to see if I see sulfur anywhere. And I do, right here at the bottom. Okay. So sulfur, in general, is insoluble. So if another substance is paired up with sulfur, it's insoluble. But if I look in my yellow box there are always exceptions to the rule. Now we know it's insoluble, but pretend we don't know. So it says if sulfur is paired up with a compound of NH4, ammonium, the alkali metal cations, remember alkali, that's group 1, and calcium, strontium, and barium. So that means that if you have calcium and sulfur, strontium and sulfur, barium and sulfur, anybody in group 1 and sulfur, it won't be insoluble anymore. That's an exception to the rule. So it'll be soluble. But unfortunately, it happens to be cadmium and sulfur. That's not an exception to any rule here. So who's making this insoluble? Well, it's sulfur. Sulfur is the one that's goofing up the flow. Okay? There's no exception to this rule. Sulfur makes things insoluble unless there's an exception. So if we look at the second test tube there, it's got iron and sulfur in there. Well, I mean, if number 2 is anything like number 1, right, we scroll back up there. Sulfur needs to be paired up with anybody in group 1, calcium, strontium, barium, or ammonium. It's not. Iron is none of those things. So what that means is it's going to remain insoluble unless there's an exception to the rule. Iron is not an exception to the rule. So who's goofing up the flow again? It's sulfur. Okay. Let's look at that third test tube with the yellow stuff in there. We've got lead paired up with iodine, the combination there. Well, this time the anion is iodine. So I'm not looking at sulfur anymore. I'm looking at iodine, which means I'm looking up here. Okay, iodine is right there. So normally, okay, so we're in a different part of the chart now. Normally, iodine is soluble, right? It's up in that upper part of the chart. But there's exceptions to this rule. If iodine is paired up, so if you trail your eyes over to the right there, if iodine is paired up with silver, mercury, or lead, it's not soluble anymore. It becomes insoluble. Well, this time it's a combination of lead and iodine. So instead of it being soluble, it's insoluble. This time, though, the anion didn't goof up the flow. Lead did it. Lead is the exception to the rule. Okay, and that last one there, it contains nickel and hydroxide. Okay, so we're going to look at that anion again, the hydroxide. Erase this. All right, normally hydroxide is insoluble. Normally. Okay, and we know right now it's insoluble, but like I said, pretend you don't. So it says hydroxide is always insoluble unless it's paired up with somebody in group 1, calcium, strontium, and barium. Well, it's paired up with nickel, and nickel is definitely not in group 1. So that means it's going to be insoluble. Who's goofing up the flow? Hydroxide is. If there was an exception to the rule, then it would be considered soluble and you wouldn't see chunky stuff. Okay? Even if you're not okay, I always have more practice for you. Don't you worry. So it says, predict whether each of the following salts is soluble in water and explain why. You always want to look at the anion, which is the second portion of that compound there. So we've got sodium phosphate. Okay. Well, we're going to look back up here in our chart to see if we find phosphate. Yes, we do. It's right there. So normally, phosphate is insoluble, meaning it does not dissolve in water, unless it's paired up with NH4 and the alkali metal cations. Well, hang on a second. What are we talking about down here? We're talking about Na, which happens to be an alkali metal cation. So this substance is no longer insoluble because Na is an alkali metal. That changes this substance from being insoluble to soluble. Okay, so it says predict whether it's soluble or insoluble. It is. This is soluble. Okay, it says tell us why. Why? Well, because there's an exception there. PO4 is paired with sodium, Na, which is an alkali metal. Okay, let's look at the second one here. CaCO3, calcium carbonate. Well, find carbonate. There it is. Okay, normally carbonate is insoluble. It will not dissolve in water unless it's paired up with NH4 and the alkali metal cations. Well, who are we working with here? CaCO3. Calcium, unfortunately, is not an alkali metal. So this substance is going to remain insoluble. Okay, insoluble. Oops. Okay, why is it insoluble? There's no exceptions to this rule. Now, if it was paired up with sodium, okay, well, that would change things, because if you look, right, alkali metals are an exception. Sodium's an alkali metal. So if it was paired up, if it said, NaCO3 or Na2CO3, that alkali metal, that pairing would make this substance soluble. But unfortunately, that's not the way that it worked out. Okay? So it's kind of like a brief explanation. Now what I want to do is kind of drill this home and do some examples with you off to the side. Okay? So let's look at this first example. How about potassium sulfite? So K2S. We'll just do some examples here. Okay, K2S. Okay, well, let's find sulfur. You look at your anion, the second letter there. Here it is. So normally sulfur is not soluble. It won't dissolve in water unless it's paired up with compounds of NH4, the alkali metal cations, Ca, calcium, Sr, strontium, and Ba, barium. Well, hang on a second. It just said that alkali metal cations are an exception to the rule. Well, that's exactly what potassium happens to be. So this substance no longer is insoluble. When you have an exception, it changes from being insoluble to soluble. Why? Because potassium is the exception to that rule. Okay, let's do another one. How about calcium nitrate? So CaNO3 2. Okay, so look at your anion, the second portion there, the NO3. Find it in your list. It's right here at the very tippy top. So normally, NO3 is soluble. It will dissolve in water. Are there any exceptions to this rule? Nope. So what that means is anybody can be paired up with nitrate and it'll always be soluble. Now, if there was an exception, then it would be insoluble. So it just kind of changes what it does. Let's look at this next one here. About lead chloride. Lead 2 chloride. Okay. Find your anion right here. So normally chlorine is going to dissolve in water. Are there any exceptions to this rule? Yep. So if chlorine is paired up with silver, which is Ag, mercury, which is Hg, and lead, which is Pb, then it changes from being soluble to insoluble. Well, this time we're working with lead, so it's not soluble anymore. It's insoluble. Who goofed that up? Well, it was, lead goofed us up. Okay, because it was an exception to that soluble rule. Okay, let's look at another one. How about NaOH? Okay, find your anion, the hydroxide, the OH right there. Okay, so normally this thing's insoluble. Are there exceptions? Yep. Compounds of the alkali metal cations. Well, I could stop right there. Why? Well, because that's what sodium is. Sodium is an alkali metal cation. So instead of this substance now being insoluble, it happens to be soluble. Sodium changed that rule. Okay, we'll do one more. Aluminum phosphate. Okay, so find your anion, your phosphate anion here. Okay, so normally this thing is insoluble. It's not going to dissolve unless it's paired up with compounds of NH4 and the alkali metal cations. Well, aluminum is not an alkali metal cation. It is not located in group 1. So this guy, unfortunately, is going to be insoluble. Okay. The basic overall gist of this, guys, is if we're looking at the top part here, the soluble ionic compounds, those substances are going to be soluble unless there's an exception to the rule. If there's an exception, then they become insoluble. And if you look at the bottom part of that chart where it says insoluble ionic compounds, those substances are going to be insoluble all the time, unless there's an exception to the rule, which means that then they are soluble. Okay, so there's rules and there's exceptions to rules. If it's an exception, it changes the rule. If you have questions, email me, let me know.